All right, welcome. Hope you are enjoying your day off. We're going to begin lesson 67 today, titled Malthus, Arithmetic versus Geometric Growth. And so, what you might be wondering is, what is Malthus? But it's not a what, it is a who. So, Reverend Robert Thomas Malthus had once observed that food supply grows arithmetically, but population grows geometrically. And the wonder there was, how can our food supply keep up with our population growth? Uh, as I said, today we're going to look at this thing called arithmetic growth. We will look at geometric growth on Tuesday. So, something to look forward to. So, an arithmetic sequence is defined as a sequence that is formed by adding the exact same value to the previous value to get the next value. For example, the sequence 4, 7, 10, 13. It's arithmetic because we're adding 3 each time. That value that we add is called the common difference, or D. It's called the common difference because if we take any two consecutive values and subtract them, we get that common difference, in this case 3. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. Always adding 3, moving from one value to the next. That common difference is going to come in handy as we move forward. So, as part of our assignment today, we are going to write two different equations. One is called a recursive equation. And in a recursive equation, the next term relies on the previous term. And it's written like this. A sub n plus 1, that's the next term, equals A sub n, the term we're previously been on, plus our common difference. For a recursive equation, you need to specify your starting value. On the previous page, our example, we would say A sub 1 is equal to 4. And then we can calculate A sub n plus 1 by taking A sub n plus our common difference of 3. And that's all there is to the recursive definition. Uh, it's easy to use, but very difficult when you're trying to find uh, numbers further on in the sequence or in the list. The other equation we're going to work with is called an explicit equation. That is an equation that can be used to find any term without knowing the previous term. To calculate uh, any term, a sub n, we take the first term, a sub 1, plus n minus 1 in parentheses times d. So in our previous example, we would have 4 plus n minus 1 times 3. And you can multiply that out and combine like terms and get a more compact equation. And we will look at that as we work through some examples. One of the things with arithmetic sequences, one of the things that we often want to do is find the sum of the first however many terms. We could just add all of those terms together, but there's a formula to make it a lot easier. If you take the first term plus the last term divided by 2, and then take that amount and multiply by the number of terms that we have, you'll get the sum of the first n terms. So that formula is going to be very useful um, today and into the future of this chapter, this unit. So for a couple of examples, we're going to do three things. We're going to write a recursive description or equation and use it to find the 10th term in our sequence. Then we're going to write an explicit description and use it to find the 80th term in our sequence. Finally, we're going to find the sum of the first 80 terms. Part A, our recursive definition. A sub n plus 1, and that will always be how we start a recursive description or equation, is going to be equal to A sub n, whatever our previous term was, plus our common difference. And I can find the common difference by just taking any two consecutive values in my sequence. So I'm going to take 37, and then I subtract from the previous, minus 34. So my common difference is 3. The last thing we need to do with a recursive definition is say, hey, we're going to start A sub 1 is going to be 34. That's where we're starting. The last thing we're going to do is figure out what our 10th term is. And when we say we're using the recursive description, that's pretty straightforward. We're just going to keep adding 3. So our 5th term would be 46. Our 6th term would be 49. 7th term would be 52. 8th term would be 55. 9th term would be 58. And the 10th term is 61. Part B, the explicit description. So I can find any term A sub n by taking my first term, 34, plus n minus 1 times my common difference, d, which we calculated above to be 3. And I'm going to rewrite this a little bit. We have 34. If I distribute the 3, we would get 3n minus 3, or if I combine my like terms, 3n plus 31. I want to find my 80th term. So I plug 80 in for n. 3 times 80 is 240, plus 31. So I have 271 for my 80th term. The last thing we're going to do is find the sum of the first 80 terms. And I'm not going to start at 34 and keep adding until I get to 271. I'm going to use the formula. Generally, the way we indicate this is S for sum, and then a subscript for the number of terms we're going to add together. In this case, 80. My formula said take the first term plus the last term divided by 2 and multiply by the number of terms we're adding. So this is 305 divided by 2 times 80. And I would just use a calculator to do that. $305 divided by 2 times 80 gives me a total of 12,200. Example 2, we have another sequence. 0.1, 0.5, 0.9, 1.3. My value for D, I take any term and subtract the previous term. So I get 0.4 as my common difference. I can then use that to write a recursive definition or a recursive equation. The next term, a sub n plus 1, is equal to a sub n plus my common difference. That is the recursive definition. I also should list my first term is 0.1. Now that definition is going to look exactly the same for every recursive definition we do for an arithmetic sequence. The only thing that's going to change is the number we're adding at the end. To find the 10th term, so I have the first 4 here. The 5th term, I would get 1.7. The 6th term would be 2.1. The 7th term would be 2.5. The 8th term would be 2.9. The 9th term would be 3.3. And the 10th term would be 3.7. Then writing my explicit equation or definition, any term a sub n is going to be equal to the first term, 0.1, plus n minus 1 times our common difference, 0.4. Again, I'm going to rewrite that so that it's more streamlined. 0.1 plus 0.4n minus 0.4. Combining my like terms, I would get 0.4n minus 0.3. To find my 80th term, I would take 0.4 times 80. So I believe that would be 32. And then I subtract 0.3. So 31.7 would be my 80th term. Part C then asks, hey, find the sum of the first 80 terms. So the sum of the first 80 terms, I take my first term, 0.1, plus my last term, my 80th term, 31.7, divided by 2. multiply by the number of terms, in this case 80. So this will be 31.8 divided by 2 times 80. And again, I would go ahead and calculate that with a calculator. Just makes it really easy. 31.8 divided by 2 times 80. And I get a total of 1,272. Example 3. Again, starting with our recursive definition, my next term, a sub n plus 1, equals my previous term, a sub n, plus my common difference. And in this case, my common difference, I'm going to take 1 minus 3. That common difference is negative 2. So yes, I'm actually subtracting 2 each time. But technically, to be an arithmetic sequence, we add the same amount every time. So we're adding negative 2. My first term was 3. So I have to list that for my recursive definition. And then if I use that to find my 10th term, let's see, we've got the first 4. The 5th term would be negative 5, then negative 7, negative 9, negative 11, negative 13, negative 15. Moving to the explicit definition, a sub n is equal to my first term plus n minus 1 times my common difference, negative 2. Again, rewriting, distributing the negative 2, we would get negative 2n plus 5. Finding the 80th term, we take negative 2 times 80, negative 160, plus 5, negative 155. Lastly, calculate the sum of the first 80 terms. So we take our first term plus our 80th term divided by 2 times 80. So negative 152 divided by 2 times 80. Again, using my calculator. And we get a total of negative 6,080. So for your assignment, I want you to work on page 473. Set 67A, do problems 1 through 9. Number 9 does have a typo. That sequence should go 923, 908, 893, 878. In the textbook, I believe it goes 923, 908, 993 instead of 893. Um, if you follow what the book has, it's no longer arithmetic and it's not going to work out. So use those four numbers for number 9. Have a great rest of your weekend. Enjoy having Monday off, and I will see you back on Tuesday.